Hi, CS50, Harvard University. I am Abhinay Rana from India, Himachal Pradesh. So, I have created this project. It may be small, but I have filed a patent over it. So, and the patent which is filed, its name is Find the Grain Bitwise Memory Allocator. The reason I did it that because I realized that the world is an open world game and what I am creating is relevant to the course. So let me explain what is actually happening in this, and then I'll run the code, and then I can just simply just talk about a little bit of details. So in standard systems, everything is forced to be in 32 bits. For example, a number 5 is to be stored. It is occupying barely 3 bits, but that 5 number 5 will be stored in a 32 bits. So that is a huge inefficiency. So this system actually fixes that by looking at your data ranges first, which will be asked in here. And for example, if your number are set between 0 and 100, the math says that we only need 7 bits max. So I force every data slot to be exactly 7 bits wide in this code. Now, for example, now if I store a tiny number like 5 that only needs 3 bits, sure, I might waste 4 bits of empty space inside that 7-bit slot. But when we compare that to a standard system that wastes around 29 bits, we are actually saving a lot of memory. Most importantly, the best part is the system treats memory like a continuous stream. If the 7 bits value runs out of space at the end of the memory block, my code automatically cuts it in halves and stitches it into the next block seamlessly. Now, talking about the code, first of all, we're gonna look into this create bit array function. Well, the basic functionality is it calculates the exact entropy of the data, finding the minimum number of bits required to store the values. Then, talking about this next one is the set value pairs. So this is the core engine. It uses the bitwise masking to inject data into raw memory stream, and it ignores byte boundaries entirely. If a number needs to be split across two different CPUs or words, right? Uh, and another one is this one is for the stitching of the uh, two words. So yeah, it automatically stitches it together. Now I'm gonna run a benchmark with 1 million integers. Yep, it's 1 million integers. So the range will be first of all we're gonna put like 200 range. Now let me clear it first. Yeah, the range is gonna be 200. So as you can see, the 1 million, there are 1 million items, and the range is from 0 to 200. And so when we use standard one, the actual the storage that is being used is 3.8. To be exact, it's 4 megabytes. But when we do the parent, which I have done, is actually using 1 megabytes only, which is actually saving 75%. Now if we do it with something else, maybe 500, like the range is from 0 to 500. Wait a minute, I'm gonna do it again. Yeah, so 0 to 500, the bits required the things is we are gonna be using 9 bits per items. So 4 bytes 4 megabytes are being used, whereas the parent one is actually doing it in 1 megabytes or 1.5 megabytes. It's actually saving 71% of, so 72% of memory. So that was my project. Thank you that I was able to access your course and you are setting it free. That's all from my side.